Hello student, this is Anup Saw from Kolkata. Today I'm going to give an idea about the velocity time graph. It's a very important chapter in motion chapter in class 11. So let's start. First of all, we draw a two horizontal and vertical lines cutting to each other at the point O. And this horizontal line, I'm supposing this horizontal line is the x-axis and this vertical line is y-axis. Now time is plotted along x-axis and velocity is plotted along y-axis, and if the equation of motion will be with initial velocity, here the initial velocity is this one, and if without acceleration I'm supposing the f is acceleration and this f is equal to 0, in that case the equation of motion will be just a straight line parallel to time axis. Okay, so if the equation of motion is just a line parallel to time axis, that is x-axis, then we say that it is without acceleration, and this line is not starting from origin, it is starting from this point, so it has some velocity, some initial velocity. That initial velocity I'm supposing u, small u. Okay, next in figure 2, here we are watching that the line, the equation of motion, this is called the equation of motion. This line represents the equation of motion and it is starting from origin, and you know that origin is actually 0 0. It's the value of x is 0, the value of y is 0, so time is equal to 0, velocity is equal to 0. It means that the body is starting with initial velocity 0. That means it was initially at rest position, but the line is moving in upward direction obliquely, that is, it means it has a slope. Okay, suppose the slope is theta. Okay, so with time, if I am going towards the horizontal direction, that is towards the right direction, we are finding that equation of motion, that this straight line is moving in upward direction. In upward direction, velocity is increasing. In right direction, time is increasing. So here we are finding that with time the velocity is increasing, and this is a case of acceleration. So there is acceleration. As the line is a straight line, so we say that the motion is uniform, but it is with uniform acceleration. Okay, so next, here in this graph I'm watching here that it has some initial velocity, let us suppose u. Okay, and the line again, it has a slope, it is starting from this point, not from origin, and as it is somewhat oblique, and so we say that there is acceleration. Let us suppose that their value of acceleration is f is equal to f. So with time we are finding that it has some initial velocity and it is moving with acceleration. This happens, suppose there is a train, it was initially moving with uniform velocity, suddenly the driver has been supposed to move in the straight line with higher velocity, so he applies an accelerator and suddenly the velocity goes on increasing. So this is the case. Next, in figure 4, velocity time graph, here I am finding that the line is moving with time, that is, if I am moving towards the right direction, the velocity is coming down, that is, velocity is decreasing. So this is a case of deceleration, that is, here f is negative, that is, there is a negative acceleration, velocity is decreasing. What is acceleration? Acceleration is just the change of velocity with respect to time, and if it is in positive sense, that is, the velocity is increasing, then f is positive, and if it is decreasing, okay, if it is decreasing, then the acceleration is called negative acceleration. Here the x, actually spelling is mistake. Okay, deceleration. In figure 4, or sorry, in figure 5, here we are finding that this is just an oval shaped equation of motion, but here the case is different, that it is a closed uh, graph, and if I am moving towards the right direction, so let us suppose from in this direction as shown in the figure, in anti-clockwise direction, we are finding that at this point the velocity is somewhat whatever, but if you go on to complete the curve, that is towards the left direction, we will find that time is decreasing. But time cannot decrease. Time is always a positive thing, it always goes on increasing. So this type of graph is quite impossible, so it's a false graph. Okay, it's a false graph. Velocity time graph like this oval cannot be possible, and like oval shape, it is a circular, or if it is a rectangle, in that case too the graph is not possible. So here I have tried my level best to give an idea about the velocity time graph. Okay, thank you for watching this video, and if you like, you could share this video with your friends and subscribe to my channel and hit the bell button to get the notification whenever I upload a new video on physics. Thank you for watching this video. Thank you.